Hi, this is Stu Bruce from Washington College. I'm going to do a lab demonstration on Module A of our 3D terrain lesson. First thing you're going to do, navigate to where your data is held. I should have a little terrain folder. We're going to bring in the DEM points. And you see we have a series of points here. We go ahead and open up the attribute table, take a look at them. Basically, we have the elevation data and the XY coordinates, so X, Y, and Z. Want to know the units of measurement, we just take a look at the projection. These are actually in meters. But if we go to properties and look at our source tab, scroll down, we can see that we are in meters. Of course, as always, make sure that your 3D analyst is turned on by Customize Extensions. And you should have a little checkbox next to 3D Analyst. Now what we're going to do here is we're going to try some different interpolation techniques to take these points here and actually create a smooth raster surface. So you're going to go ahead and open up our toolbox. And in the 3D Analyst Tools, under Raster Interpolation, first tool we're going to run is IDW. Basically, we're going to bring our points over. It will automatically recognize, since there's a field called elevation, it will pull in that field. You're going to go ahead and select an output location. So in your output location here, I actually went ahead and did these already, but I created a file geodatabase. If you don't have one, there's an option right here to create a new file geodatabase. But just save it as your last name and then the name of the technique that you're running. So I'm going to call that like that. And then your output cell size, I'm going to go ahead and make 10. And then you're going to leave the other options alone, and you go ahead and click OK. Should process pretty quick. When you're done, you'll see some results like this. Basically, the ground values, the lighter values are the higher elevations. So our top range is 23.19 meters, and our low range is down here. If we turn our DEM points on, we can kind of see the spread. And if you want to actually label the points, you can do that by coming into DEM, select Labels, go ahead and change your label field to elevation, like so. Click Label Features in this layer, then you can click OK, and you can go ahead and you can zoom in and kind of get a better idea of what's actually happening here. So that's IDW. Seems to do a relatively decent job. The next one that we're going to do is we're going to go ahead and run the spline tool. So open up the spline tool, and the same thing, bring our points over. Our Z value field is elevation. Go ahead and put it inside your geodatabase, like so. Click Save. Make your cell size 10. And for this exercise, I went ahead and changed this to the tension. I think it works a little bit better. And I leave the others as default, and I go ahead and click OK. So take a look at your results. One of the things that I noticed right away when I do spline is notice how kind of choppy looking the IDW is. The spline gives you a much smoother sort of contours. We can zoom out and take a look at the overall image, like so. Sometimes it helps to turn the DEMs off. This looks a little bit smoother, a little bit less choppy. Kind of why I like spline a little bit better. The next one we're going to try is we're going to try creaking. Go ahead and open up your creaking tool. Same thing, bring our points over. We'll set our output raster to creaking 2, since I already did this one time already. Hit save. Now you do have a lot of other options here. In the model, or basically in a lesson, I'm going to have you do the Gaussian, but you could play around with these and you get some slightly different results. Go ahead and pick 10, and then just click OK. So you really get quite a different look with creaking. It's kind of a broader interpolation. It doesn't have the detail that we had, for example, in spline. I don't think it does a very good job of showing for elevation. And then the last one we're going to try natural neighbor. And in natural neighbor, we'll bring over our points. Same thing, we have to find the output. So here's natural neighbor 2. And we'll just keep the same cell size as 10 and click OK. Now, Natural Neighbor does some kind of funky things. If you look up here, got some kind of weird interpolation results. I think it really does a horrible job for this particular application. So I would suggest you not actually use that. Now, the assignment for this lesson is pretty simple. We just want you to come pick which method you thought worked best. Maybe you disagree with me. You think creaking is pretty cool. But go ahead and just do a quick little map layout and clean up your legend a little bit so we don't have all these sort of odd numbers, and you'll upload that for your assignment. And that's it for this lesson.